Hello everyone. Now we'll be studying the chemical properties of benzene from the chapter of hydrocarbons in class 11th. So in benzene chemical properties, we have to do three types of reactions, that is electrophilic substitution, addition reactions and oxidation reaction of benzene. Now electrophilic substitution reaction, if we see, it is represented as SE. S means substitution, E means electrophilic. Before we go on to the reactions, let's study the mechanism. How does benzene react? How can it react? Now, mechanism, it has three steps. That is generation of electrophile, then formation of carbocation intermediate, and removal of proton from the carbocation intermediate. Next thing is, let's do the first step, generation of electrophile. So benzene being electron rich will attract which type of attacking reagents? It will attract the electrophile towards itself, okay, which are the electron deficient species. So first of all, we have to generate the electrophile. So how is that generated? Let's see. It depends upon the type of the reaction or which substitution you have to do on the benzene ring. Suppose you have to do chlorination, okay, so you require a chloronium ion as electrophile. If you want to substitute an alkyl group, you require a carbocation. An acyl group, you require a carbocation of the acyl group. And for nitration, you require nitronium ion. So how are these electrophiles generated? Now for the first three reactions, chlorination, bromination, or for Friedel-Crafts reaction, we use an anhydrous aluminium chloride as the catalyst, which generates the electrophile. For example, Cl2 when treated with anhydrous AlCl3 will give Cl4 positive due to the breaking of this bond. So in this case, this Cl-Cl bond breaks. How does it break? It breaks by a heterolytic fission like this. So AlCl3 being electron deficient will take up the Cl negative, okay, and it form AlCl4 negative. So this is formed by combination of AlCl3 plus Cl negative, and you are left with Cl positive over here. So that is how the chloronium ion is generated for substitution. Next is for Friedel-Crafts alkylation and Friedel-Crafts acylation. We substitute the acyl group or alkyl group again in presence of anhydrous AlCl3. So being the same, it is electron deficient, it is a Lewis acid, anhydrous AlCl3. So what will it do? It will pull out chlorine along with these electrons. So these Cl negative goes here and you are left with the carbocation. Similarly, in this case also, Cl negative will go with AlCl3, will be taken up by AlCl3, and you are left with this carbocation as a catalyst. For nitration, we require sulfuric acid as a catalyst. What does the sulfuric acid do? It is concentrated sulfuric acid. It first provides a proton to the nitric acid. It provides a proton, protonates the nitric acid. From the protonated nitric acid, water molecule is removed, leaving behind the nitronium ion. As you can see, oxygen gets a positive charge due to protonation. So oxygen pulls this bond pair of electrons and form H2O, which contains, oxygen contains two lone pair, and you get the nitronium ion. So in this step, so we have generated the electrophiles which can attack the ring. So next is the formation of the carbocation by the attack of the electrophile on the ring. So as you can see over here, when this electrophile approaches the ring, you have a hydrogen over here, you have a hydrogen over here. So electrophile doesn't have any of its own electrons to form the bond. So what will it do? It will take up these pi electrons. So E positive comes here and this EC bond is formed. Now, due to the formation of this bond, what happens over here? This carbon is now tetravalent. It is, although all the carbons are tetravalent, it is now attached to four groups, H, E, and C on this side and C on this side, C positive on this side. So it has become sp3 hybridized. Okay, it is no longer sp2. All the carbon atoms in benzene ring are sp2 hybridized. Now this one has become sp3 hybridized. sp3 hybridization, geometry becomes tetrahedral. Okay, so such an ion is known as the adenium ion, or it is called the sigma complex, because this doesn't contain, this part does not contain any pi bond now. Okay, and the delocalization of the pi bond has stopped in fact. Okay, so why is this ion formed? Kyun banta hai? Why does this reaction proceed? Because this adenium ion is stabilized by resonance. As you can see over here, you have a positive charge on this carbon. So pi electrons move over here, you get positive charge, and same way you get positive charge on this person. So if you see the resonance hybrid, you have a positive charge on the ring. So that is why it is called the adenium cation. Okay, so the delocalization, the only thing is this cation is no longer aromatic. Why? Because the delocalization of the pi electron stops at this position. Stops where? Where the carbon atom is sp3 hybridized. So it is extending up to this side only. So that is why it is no longer aromatic. Now next thing is, to restore the aromaticity, what will this ion do? It will lose a proton and take up those electrons to form the pi bond. How? As you can see over here, it will take up these electrons to form the pi bond, resulting in the loss of a proton. Proton will be taken up by AlCl4 negative and it will form HCl and AlCl3. And you get a electrophile attached over here. Okay, so AlCl3 is a catalyst. Why? Because used up in the first step and regenerated in the last step of the reaction. So that is why it is a catalyst. Same as for the nitration. The H positive is lost from here and the CH bond electrons move inside and forms the pi bond. So you get nitrobenzene and sulfuric acid is again regenerated. So hence it is a catalyst. So let's see the individual reactions now. So chlorination mechanism, all these reactions follow the same mechanism. So if you see the individual reaction, chlorination, when you treat it with chlorine in presence of anhydrous AlCl3 or FeCl3, FeCl3 will also do the same work. It will take up the Cl negative from chlorine molecule. Chlorobenzene is formed. Similarly, if you carry out bromination in presence of anhydrous FeBr3, you get bromobenzene. Nitration, as we have just done, in presence of concentrated HNO3 and concentrated sulfuric acid, you get nitrobenzene. Next is that there are two Friedel-Crafts reactions. Friedel-Crafts reactions. One is alkylation, the other one is known as acylation. So alkylation means substitution of the alkyl group. Acylation is substitution of the acyl group on the ring by the same process. Now in this case, suppose you carry out the chlorination. This chlorination, if you carry out with excess of chlorine, okay, anhydrous AlCl3, what happens? Instead of mono substitution, substitution of one chlorine, you get the poly substitution. Chlorine atoms can be substituted at all these positions. As a result, what do you get? You get hexachlorobenzene or C6Cl6. So that can also happen if you treat it with excess of chlorine. So these are the electrophilic substitution reaction of benzene. Characteristic reactions of benzene, electrophilic substitution. Why? Because the ring of benzene is electron rich. It contains 3 pi bonds. So next set of reaction is addition reactions. Benzene also undergo addition reactions, but not as easily as the electrophilic substitution reactions. Why? Because benzene does not act as a normal alkene. It doesn't undergo addition reactions like normal alkenes. Why? Because these pi electrons, although it contains 3 pi bonds, these pi electrons are delocalized over the ring. They are not localized between the two carbon atoms. So due to this delocalization, the addition reaction, if it has to occur, it occurs at a high temperature and a high pressure under special conditions. For example, benzene undergo hydrogenation when treated with nickel, and when heated to a high temperature, it forms cyclohexane. Similarly, it undergoes addition of chlorine. Again, in presence of UV light. So remember these reactions, this chlorination is done in dark. You must distinguish between these two. So this is generally carried out in dark. So in that case, you get substitution reaction. When the same reaction you carry out in presence of sunlight with excess of chlorine, what do you get? You get the addition reaction now. So this is C6H6Cl6 and it is called benzene hexachloride or gamexene. Basically, it is used as a pesticide and insecticide. So try to distinguish. Remember, this is C6H6Cl6, which is formed by addition reaction. We did the same thing over here. Okay, in presence of chlorination, in presence of anhydrous AlCl3 dark. In this case, you get substitution. Substitution means your hydrogens are replaced by Cl. It is not addition. Ring is still there. Hydrogen atoms are replaced by the chlorine atom. So it is C6Cl6. And this is your C6H6Cl6. So that is the difference. Okay. So next is combustion. Benzene burns in air with a sooty flame. It produces carbon black. Okay. And this is the equation for the reaction. So with that, we'll finish with the chemical properties of benzene. Bye and have a safe day.